bouncing ball by Mercedes, Amelia, and Emke. In most collisions, kinetic energy is lost from the system and converted into other forms like sound and heat. These types of collisions are called inelastic collisions. The amount of energy lost in a collision depends on what the object is made of, and the mass of the object. Similarly to how friction changes with different surfaces, we measure how bouncy a collision is using a coefficient of restitution, or CR, which is the ratio of the object's relative velocities before and after the collision. The purpose of the lab was to determine the coefficient of restitution for two different balls, different materials colliding with the ground for its set height. We were able to use the formula CR equals square root of height 2 over height 1 to determine the values. The methodology includes
Our methodology includes setting up a tripod and recording device, which is a phone, along with setting up the backdrop. We then measured a 1 meter mark along with a 2 meter mark as our 1 meter measurement requirement. We recorded 2 sets of data for each ball of 5 bounces each. We recorded a set in regular time and slow-mo video. Then we were ready to analyze the data through Tracker app and determine the values for the coefficient of restitution. On to the data analysis. This is the Excel sheet for our data analysis to determine the coefficient of restitution. The balls we decided to observe were a tennis ball and a golf ball. Our data was moderately accurate and the balls both have similar CRs, although it's also distinct, which is bouncier per se. We think they're similar because they have similar materials, although different structures for their sports advantages. The coefficient of restitution for the golf ball was 0.841. The coefficient of restitution for the tennis ball was 0.651. Both of the coefficients are between 0 and 1, which shows a realistic outcome for the experiment. The kinetic energy for these systems when the balls hit the surface is not conserved, as viewed through the data that shows the decrease in height of the subsequent bounces. The momentum is also additionally not conserved due to external work of gravity and other forces that can be acting, such as air resistance and axis tilting. Now for uncertainty and precision. We had a measurement of plus or minus 0.1 uncertainty for our height measurements. Other main sources that factored into uncertainty and error include human error of calculating heights, a parallax error in video measurement, bounds not perfectly vertical, camera angle tilt. Average propagated uncertainties are on the spreadsheet for referral if needed. For the reflection, due to this lab and experiment, some things we learned include learning applied physics of energy conservation and coefficient of restitution in real motion, an improved understanding of uncertainty propagation, and gained additional experience with Tracker app and Google Sheets functions and formulas.